Okie dokie. What we have here is we are doing 7.2, day 2, and talking about biased and unbiased estimators. Now, when we talk about estimators are really statistics. All right, statistics. All right, statistics try to find out more about a population. All right, so when we use stats try to give us information about a population. All right, offer. I'm going to say insight. That's a cool word. Insight into a population. And we can talk about these, all right, estimators as being, for example, what is the mean? So we have a sample, all right, how does that relate to the mean of the population? When we have all right, a proportion, all right, how does that relate to the proportion of the population? And when we have a standard deviation, all right, how does that relate to the standard deviation of a population? All right, so this is our stats. So biased and unbiased estimators can lead us into discovering whether or not our statistics are good. Okay, so a unbiased estimator is a statistic that is an unbiased estimator if the mean of the sampling distribution is equal to the true parameter. And so essentially, if we take a sampling distribution and it is unbiased, if we realize that yes, the actual mean is actually pretty close, all right, to the sampling mean, all right, the sampling mean, all right, when we find that. Now, if we realize that our sampling mean is over here, but our true mean is on over here, we would say that would be biased. They are not equal. That's bad. Bad. All right. Now, so that is what an unbiased estimator is. Unbiased means that the sampling mean is equal to the true mean of the population, and that is good. Yay, happy. All right. Now, variability. Now, we talk about variability. Variability is how far the sampling mean will be from the true mean. And so how can we decrease variability so we have more of an unbiased estimator? Well, two different things. And you've learned this before in your previous things, and it makes sense, is that you want to increase sample size. All right, sample size. All right. If you increase sample size, you decrease variability of the statistic, okay? So increasing sample size decreases variability, all right? And that's what we talk about replication. The more and more values you have, it kind of applies to like the law of large numbers. The more times you do it, all right, the less variable your value is going to be. It's going to start closing in, converging on what the true mean proportion to be what it would be. Okay, and that's what we have there. Okay, so increased sample size will lower that. So with that, let's go through a problem. Check this out. Once again, thank you, Statsmatic, for all of your helpful work. All right, so check them out if you ever want to know more information about stats. Awesome, Statsmatic. All right, so the histogram on the left shows the interval in minutes between the eruptions of Old Faithful geyser for all 222 recorded eruptions during a particular month. That's a lot of eruptions. For this population, the median is 75 minutes. Okay, so for this population, so we know the median, and we could say, all right, the median minutes right there. So we use technology to take 500 random samples of size 10. So our n value is 10 of the population. The 500 values of the sample median are displayed in the histogram to the right. Okay, to the right. Okay, all right. And so this is what we have here. So this is the one just to the right, right there. Okay, so when we have this, the mean of these 500 values is 73.5. Okay. And so the question is the sample median an unbiased estimator of the population median just for an answer? Well, the answer is no. No. Um, the no. The sample median of 73.5, all right, is not equal to the population median of 75. Okay, of 75. All right, 75. So the sampling median, would say, is biased. Is biased. And that's what we know. All right, well, that makes sense. Okay, so because they're not equal, it's biased. All right, so suppose we had taken a sample size of 20 instead of 10. So we increased the sample size. So we increased the size. All right, so we increased our n value. All right, so would the variability of the sampling distribution, so we're talking about variability of the sampling distribution of the sample median, be larger, smaller, or about the same, just for answer? Well, the sampling distribution variability would be smaller. All right. All right. So the sampling distribution variability would decrease or be smaller. All right, smaller because of the increase in sample size. All right, and that's what happens. So you increase sample size, you decrease variability or make the variability smaller. Okay, so, and then finally, describe the shape of the sampling distribution of the sample median. So how would you describe this? Well, this appears that we're going to have right here. So if we would describe this, it appears to be skewed to the left. All right, skewed to the left. All right, so the sampling distribution of the sample median appears to be unimodal, means it only has one peak, unimodal and skewed to the left. Okay, and hopefully you agree with that. So unimodal and skewed to the left. The other one appears to be bimodal, and maybe also you could say is slightly skewed to the left as well. So in any case, so unbiased estimators, going through this and just think about it. So just kind of recap again. Unbiased estimators mean the statistic is unbiased if the mean of the sampling distribution is equal to the parameter. All right. In this case, we were talking about medians in this past example. All right. So we want them to be equal. Variability, once again, increase sample size, decrease variability of the statistic. All right. And your distribution. All right. So with that, good luck and God bless the rest of your problems. And happy